So our last video, we looked at humoral control, where we have one gland basically bossing around another gland saying, hey, you, let your hormone out. Now here, we're actually going to let the gland respond to its environment directly. And so this is going to be humoral control. So humoral, from what they used to call the humor, as being the fluid within the body. So in this case, really, we're focusing on blood, and these organs are directly monitoring that blood and saying, hey, you're a little off on something. We need to increase that or decrease it. So let's talk about first how that process works and just get a refresher on a negative feedback loop. So remember, in your body, we always are trying to maintain homeostasis. So homeostasis, I always like to picture it as like a little box that we're trying to stay within. That is basically going to be your job, or the job of anybody who works in healthcare, is maintain homeostasis for your patient. As long as that's happening, you're good. It's a good day at work. Any illness or death, that's when we've deviated out of that box. So we're going to have mechanisms in place to constantly monitor if we are within homeostasis or not. So the first thing that you'll have is you'll have a stimulus, some kind of change. And that is always noticed by a receptor. Receptors can't do anything about that change, but what they will do is that they'll monitor that environment, notice when something has changed. Because again, it's change that'll kill you. If it's inside of the box, we don't care about it. But if there's a change outside of that box, the receptors will identify it and they'll send that information to a control center. Control center is basically a location that can receive information and then figure out what to do with it and then send commands out. So it's a communication component, which means it's either going to be an endocrine gland or it's going to be a neural structure. So since we're talking endocrine, we're going to focus on it being an endocrine gland. So that control center is going to send a signal out. And again, if this is an endocrine structure, this signal here is going to be a hormone. So we're going to release a hormone to an effector. Effectors are capable of, guess what? Causing an effect. They cause a change. So typically that's going to be a muscle or a gland. So we're doing something in response to whatever that hormone is that was released. It could be a cell that's storing something. They're going to release it. And so we're going to have the stimulus basically being opposed on this end. So whatever your change was, over here, you're going to be the opposite. So I'm going to think of this as my solution. And that's what makes this a negative feedback loop, is that you're always opposing the stimulus. Whatever the change is, you're taking that change away in that solution. So if you're looking at a stimulus as an increase in something, your solution is to decrease that something. So this is a negative feedback mechanism. And so I want to talk about a few examples of when we would do that. So again, if the stimulus is you want to increase, or the stimulus was that something increased, then the solution is you want to decrease it. Or if it's the opposite, if your stimulus decreased, then your solution is to increase whatever that was. And so there are three that I really want us to focus on for our notes. One has to do with calcium. So if you're looking at calcium, if levels are too high, that would be our stimulus. Our solution would be to decrease calcium. And specifically, we're talking about in blood. Calcium is needed for muscle contraction and neural signaling. So we have to make sure we always have some available to use. So we're really interested about how much we have in our blood. Our bones hold onto it for us for storage. But realistically, the place where we need to make sure we have the right amount is in our blood. So calcium, the levels are too high. That's your problem, right? That's your stimulus. The solution to that is the opposite. We want to lower those levels. The control center for that is going to be the thyroid gland. So I'm going to do control center. So we're going to have thyroid. And then the hormone that the thyroid gland is going to release is going to be calcitonin. So calcitonin, the trick here is it tones it down. So that's how I remember this one. So my problem is that you are too high. We want just to tone it down. We want to store it up. We're going to release calcitonin. Calcitonin comes from the thyroid gland. Now, if we look calcium the other direction, if levels are too low, then our solution is to increase blood calcium. Our control center for this one is really close by. Instead of thyroid gland, you're going to have parathyroid gland. And the hormone here is parathyroid hormone, or PTH. But again, same idea. you're doing the opposite of whatever the change is. So parathyroid hormone is released in response to levels being too low, and you want to increase them. Another example where you do this is going to be dealing with sugar. Now, with the ones with the blood sugar, let's just kind of simplify life a little bit here. So we're staying in these same bars, if you will. So sugar, let's say the stimulus of the problem, let's just say it's increased sugar or decreased sugar. Those can be our problems. Our solution is the opposite, right? So if it's too high, we want to decrease sugar. If your problem is that it's too low, we want to increase sugar. Now, this one's a little bit more convenient than our last example because your control center for both is the same structure. So this is going to be the pancreas here. So I'm going to figure out how to do that. Do it this way. So you get pancreas for both. Now, the difference is just which hormone the pancreas releases based on the problem. So here I think of this first one. Actually, let's do it this way. I like this one better. So if we have a decrease in blood sugar, I think of glucose is gone. And if glucose is gone, we want to use the hormone called glucagon. So glucose is gone, we're going to use glucagon. If it's too high, then we're going to use the one that you're probably familiar with, and that's insulin. Because people who are diabetic, they have a problem regulating that blood sugar, they might have to ingest insulin instead of their pancreas producing it. All right, and then the last one I kind of want to talk about in here is our blood pressure one. And so we have blood pressure. And again, we're going to go through the two directions. We'll have an increased blood pressure, and then we'll have a decrease in blood pressure. The solution is the opposite of that. So decreased blood pressure or increased blood pressure. So if you're looking at which hormone is going to decrease our blood pressure, the answer to that is ANP, atrial natriuretic peptide. The structure that's going to release that, the control center, is actually the heart. So the case of the heart saying, yeah, I'm working way too much right now. I need to make this easier. So the heart's going to want to lower blood pressure. That's the way I always remember it. And atrial natriuretic peptide, atriums are the top chambers of the heart. So they're the ones really noticing that blood that's being returned is like, oh, this is too much work. I'm having to deal with too much pressure. So the atrial natriuretic peptide, meaning that molecule is coming from the atriums of the heart. This one over here, if your blood pressure is too low, that really can affect our kidney's ability to filter. The kidney is getting a sample of blood. The way that they get that sample is actually based on blood pressure. If blood pressure is too low, the kidney can't get its sample. So the kidney is your control center for this one. And that kidney is going to release something called renin. And that's going to do a whole bunch of things that we'll talk about later. But for now, the basic idea is renin is going to increase our blood pressure. So those are some examples of just different hormones that we've got in the notes where we talk about how they do different things for that negative feedback loop. Now, there's one other thing that I did want to give some advice on that students do tend to get stuck on a little bit in the notes, and that has to do with the fact that they both have the same target, and they both actually are very closely related in what they're doing, and it has to do with milk release. And so there are two that deal with milk release, and that's prolactin and oxytocin. So the trick here is prolactin is for production. So this one goes first, prolactin produce. Oxytocin is for secreting. So this is letting it out. So this is for release. Now, they're also different based on where they come from. So prolactin is from the anterior pituitary. And then the oxytocin is posterior pituitary. So that is another difference between the two. So if that kind of helps, I know that's something that students sometimes get stuck on because these both go to the mammillary glands and have a role with milk. So prolactin comes from anterior pituitary. We'll release that one first to get production to occur. And then the posterior pituitary will release oxytocin to get that milk to be released. All right, everyone, I hope that helps make some more sense out of these hormones for you.